Okay. All right. So we are going to be talking about today understanding some things about fractions. All right. The first thing that I want you to understand is if I take a whole circle and I break it into two halves. Okay, so we've taken that circle and we have broken it down into two halves. The two halves are equal to each other because they came from the same whole part. So just like today for the warm up, this doesn't work if the parts don't come from the same whole amount. Okay, so we've got to have the same whole in order for the fraction pieces to be the same. So I could take those two halves, and I'm going to take one of those away. But if I took one of the halves and broke it up into half, and this is really what we've been doing with some of those warm-up exercises that I've had you do, then we know that each of these pieces is a fourth of the whole circle. Well, that means that 1/2 is exactly the same as 2/4. We can write 1/2 equals 2/4 because they're both the same amount of the whole circle. I could also take the 1/2 and I could break it into 3 equal pieces. And so if we take the 1/2 and we break it into 3 equal pieces, each one of those pieces is a sixth of the whole circle. Because to have a whole circle, I'd have to have 3 more, and that would give us 6. So 1/2 is exactly the same as 1/4, which is actually the same as 3/6. Okay? I could go further and I could say, all right, if I took that 1/2 piece and I broke it up into 4 equal pieces, okay, so I've taken the half and I've broken it up into 4 equal pieces. I would need 4 more to make a whole. So each one of these pieces is an eighth, and I have 4/8. All 3 of these amounts are the same. All 3 of those are equal pieces, just written and looked at in a different format. So 1/2 is the same as 2/4, which is the same as 3/6, which is the same as 4/8. And I could keep going. If I wanted to change this into tenths, then it would be 5/10. I could go even further than that. If I decided to break the 1/2 piece into twelfths, well, if I take the 1/2 and I break it up into equal pieces that are Put them on here first. No. And then I'll count them up for you. Okay, so if I take the half and I break it up into 1, 2, 3, 4, 5, 6 equal pieces, then I would need 6 more to make a whole circle. So each of these is a 12th. All right. And so 1/2 is also 6/12. Okay. So 1/2 is the same as 2/4, which is the same as 3/6, which is the same as 4/8, which is the same as 5/10. I don't have any tenths pieces, so I can't do, or do I? Yeah, I do. I'll be darned. Here are tenths. Let's see. We should be able to get 5 of these 1/10 pieces to fill up 1/2. Okay. So if we took the half and broke it up into 5 equal pieces, then each of those pieces is a tenth of the whole circle. So half are 5/10. Okay? Is that making sense? I want to make sure before we go on that that is making sense. And that you're making that visual, yes, it's okay. You're making that visual connection. That's what I want you to see here, is that we've got a visual connection. The 1/2 being the same as each of these sections. We've just divided them into different pieces, but all of those are equal to each other. Okay? So if I go back to the 1/2 right here, and I turned it into fourths, then what I would have to do is multiply the bottom by 2 to get 4. And if I do that on the bottom, I have to do that on the top. And so 1/2 times 2/2, which is just 1, 2/2 is 1, we get 2/4. If I take 1/2 and I want to turn it into sixths, okay, so now I'm turning 1/2 into sixths. I would have to multiply the bottom by 3 to get 6. And if I do that on the bottom, I have to do that on the top. 1 times 3 is 3. We haven't changed the value. The amount is exactly the same. We are just writing it in a different form. But all of them are equal to each other. And when we took 1/2 and multiplied it by 2/2, we were multiplying by 1. 2/2 is 1. When we took 1/2 and multiplied it by 3/3, we were multiplying it by 1. If I take 1/2 and I want to turn it into fourths, okay, 1/2 to be turned into fourths, then I would have to multiply, oh, we already did fourths, I'm sorry. let's say we're going to take 1/2 and we're going to turn it into eighths. Then we would have to multiply the bottom by 4 to get 8. 2 times 4 is 8. And we would then have to multiply the top by 4. 4 times 1 is 4. So 1/2 is the same as 4/8. We multiplied 1/2 by 1. We just wrote 1 in a different format, 4/4, so that we could write the fraction in a different format. We haven't changed the amount that the fraction is. It still represents the same chunk of pie or pizza. We still have half a pizza no matter which way I take that half and slice it. If I leave it as a half, if I take the half and cut it in half and make fourths, if I take the 1/2 and cut it into 3 equal pieces, each being a sixth, or if I take the 1/2 and I chop it into 4 equal pieces, each of those pieces being 1/8 of the whole pizza, or if I chop it into 5 equal pieces, each piece being a tenth and having 5/10, all of those are exactly the same thing. Okay? So it's important that you see that we are taking a fraction and we are just multiplying the top and bottom by the same number, which is 1, to turn it into a new fraction. So if I were to ask you this, I'm now going to take the pictures off. You need to be able to make the connection with the pictures, but then we need to move from the pictures to the arithmetic. Okay? To the arithmetic. So give me a second to pull all these off without losing them. Okay, and I'm going to switch that off, but I'm going to switch to this. Okay, so what if I gave you the fraction 2/3? And I wanted to know, all right, I want to change 2/3 into twelfths. I want to change 2/3 so that it is twelfths, being exactly the same amount. I want 2/3 to be the exact same amount as something twelfths. Okay, so I would have to multiply the top and bottom by what number? Good, good, 4. So careful, Corey, we're not multiplying by 1/4. We're multiplying by 4/4 because the number on the top and the bottom have to be the exact same number. So if I'm going to change 2/3 into twelfths, we have to multiply the top and bottom by the same number, and that number is 4 because 3 times 4 is 12. 2 times 4 is 8. So 2/3 is exactly the same as 8/12, which means that if I had a circle and I chopped it up into 2/3, I took 2/3 of it, and I then took those 2/3 and made twelfths, I would have 8/12 colored in. That would be exactly the same amount as the 2/3. All right, let's try another one. If I gave you 4/7, 4/7, and I want to turn 4/7 into 21sts, 21sts, then I need to multiply 4/7 by 1. We're multiplying by 1, but what are we writing 1 as? It would be what over what? What number on top and bottom? Careful, type in careful. We're not going to multiply by 1/3 because if we multiply by 1/3, we haven't multiplied by 1. And so our fractions won't be equal to each other. So 3/3, correct. We would multiply by 3/3 in order to get 21sts. 7 times 3 is 21. 4 times 3, 12. So 4/7 is exactly the same amount as 12 21sts. Okay? All right, let's do another one. This one I'm going to let you try by yourself. If I have 1/9 and I want to turn 1/9 into 27ths, I want to know what is this number up here on the top? Ladies? Y'all letting the men dominate here. Mm-hmm. Okay. Exactly. Because in order to get 9 to turn into 27, we would have to multiply the bottom by 3. If I'm going to multiply the bottom by 3, I have to multiply the top by 3. And when we multiply the top and the bottom together, 9 times 3 is 27. 1 times 3, 3. Okay? This is why we've got to be able to switch from the visual and be able to do the arithmetic, because now it becomes too hard to try to start breaking circles up into 27 equal pieces. It's hard to draw that and be able to understand what it is you're seeing, because it's just too hard to draw something in 27 equal pieces. It's tough. So we've got to be able to do the arithmetic for that instead of looking at the pictures. But at the same time, we need to realize that that's what we are doing. We are taking 1/9, we are dividing it into equal pieces, and then we are counting how many of the whole circle that we have that's colored in that's the exact same amount as 1/9. Okay, you're all right. A good bit of the time on the GED, you're going to have a calculator. So, all right. Now we're gonna do one more of these, but I'm gonna switch things up on you. We're gonna start with 3/4. Yeah, for real. Absolutely. There are only a few questions, a small amount of the questions that you don't have a calculator available. Now, you don't get to walk in there with a calculator. You don't walk in there with your phone or a calculator or anything like that. But at the top of your screen, there's a calculator button that you can click, and it'll pull up a calculator on the screen for you to be able to use. Okay. Let's see. So here's one more, but I'm going to change it up on you. I want 3/4. Let's let me do this. I want 3/4, and you're going to multiply it by something so that we get 12 somethings. I want to know, what is this number right here? Ashley, what do you think? What did we have to multiply the top and bottom by here in order to get right? We'd have to multiply the top by 4 and the bottom by 4, because this is just 1. We haven't changed the fraction. But if we're going to turn the fraction into something other than 3/4 that it's going to be equal to, then 3/4 is the same as 12/16. Okay, so 3/4 is equal to 12/16. All right, so taking a fraction and converting it into another fraction that's equal to that fraction. Now what we're going to do is work backwards. We're going to take a fraction that's already had something multiplied by it on the top and bottom that gives us a new fraction, and we want to reduce it back down to the base fraction, the fraction we would have started with that it's equal to. Okay, so all right, so now we're going to take a fraction, and we're going to want to reduce that fraction down to the lowest possible terms. So the way we do that is we take the number on the top and we factor it down. We divide it down. I know that 10 is 2 times 5. Then we look at the number on the bottom. 15 is 3 times 5. We can't break the 2 down any further. We can't break the 5 down any further. We can't break the 3 down any further. We can't break the 5 down any further. But these 5s are common factors. They can divide out, because remember, 5 over 5 is just 1. And so we're really just dividing out, or pulling that 1 out from the fraction, from the factors of the fraction, and we end up left with 2/3. Okay. 4/16. 4 is 2 times 2. 16 is 4 times 4. Well, the 2's cannot be broken down any further, so those are just 2 times 2. But each of these 4's is 2 times 2. So we took this 4 and broke it down into 2 times 2, this 4 and broke it down into 2 times 2. And now I see that this 2 can divide out with that one, because that's 1. and this 2 can divide out with that 2 because it's 1. And then, oh, wait a minute, there's no number left on top. But really there is. 1 is always a factor. And so on the top, we're left with 1. On the bottom, we're left with 2 times 2, or 4. 4/16 is exactly the same as 1/4. Because to turn 4/16 into fourths, I'm sorry, backwards. In order to change 1/4 into 16ths, like doing earlier, I would have to multiply the top and bottom by 4. 4 times 1 is 4. 4 times 4 is 16. So we're taking what we did earlier and we're just working backwards from it, okay? Let's do 15 over 25. 15 is 3 times 5. 25 is 5 times 5. Those don't break down any further, but 5 is a common factor for the top and the bottom. We can divide it out because we're just pulling that 1 out, and we're left with 3/5. 15 25ths is exactly the same as 3/5, because if I had started with 3/5 and I had asked you to turn it into 15 25ths, you would have to have multiplied the top and bottom by 5, 5 over 5, or 1, in order to rewrite the fraction as another fraction that's the same amount of pieces, the same amount of the whole circle, okay? All right, let's look at this one. 14 over 21. 14 over 21. 14 is 2 times 7. 21 is 3 times 7. Those don't factor down any further, so I can divide out the 7s, and I'm left with 2/3. 14 21sts is exactly the same amount as 2/3, just written in a reduced or simplified format. Okay? If we had started with 2/3 and I had asked you to turn this into 21sts, you would have had to multiply the bottom by 7 and the top by 7 to turn 2/3 into 21sts. So you need to be able to go forwards and you need to be able to go backwards. But the process, what you're doing, is exactly the same thing. It's just if I take this fraction that's in the reduced form and I turn it into a fraction that's not reduced, I had to multiply top and bottom by something. If I start with a fraction that's not reduced and I want to reduce it down, then I'm going to find out what numbers I multiplied the top and the bottom by to get that number, and then divide out the things that are in common. Okay, one more. 16. 16 is 4 times 4. 100 is 10 times 10. Well, 4 can be broken down some more. This 4 is 2 times 2. And this 4 is also 2 times 2. Here, 10 is 2 times 5, and this 10 is also 2 times 5. All of that's broken down as far as it'll go, so I can divide out that group of 2's and that group of 2's. Nothing else will divide out, so I get 4 on the top, 25 on the bottom. 16 100ths is the same as 4 25ths. Now, sometimes you can save yourself a lot of work if you know already what's going to go into the top and what's going to go into the bottom. For example, when he did the problem 30 over 36, I could factor this down: 3 times 10 on the top, 6 times 6 on the bottom. The top is 3 times 2 times 5. 3 times 10 is 2 times 5. 6 is 2 times 3. And 6 is 2 times 3. And then divide out the 3's and divide out the 2's and be left with 5 over 6. But if I think ahead first and I realize, all right, I have 30 on the top and I have 36 on the bottom. Is there a number that will go into 30 that also goes into 36? Well, I know that 30 is 6 times 5. And I know that 36 is 6 times 6. 6 goes into 30, 6 goes into 36. I can now divide out those 6's and be left with 5 over 6. I got the same answer. One method, I factored it all the way down. The other method, I said, all right, I know that the top is this times this and the bottom is this times this, and two of those factors are going to be the same amount. We still went down the same road. It's just one way is a little bit longer and the other way is a little bit faster. We're going slower down the road to get our answer this way. We're going down the road faster to get to this way. Either way is fine because we want to get to the end of the road. Okay? As you get better at this, you will get faster. You will start to see, okay, I'm looking at a number on the top and I'm looking at a number on the bottom, and I know something goes into both the top and the bottom, and I'll factor it out. Sometimes you may factor it out and you don't realize that you have finished factoring it out. For example, if I took this same 16 over 100 and I said, well, I know 2 goes into 16, it goes 8 times, and 2 goes into 100 50 times. All right, well, those 2's divide out, but I'm not done. Because now I look and see, oh, wait a minute, 8, I know that 2 will go into 8 4 times. And I know that 2 will go into 50 25 times. The 2's divide out, and I have 4 over 25. I still got to the same answer. I just went a little bit longer out of the way. Okay? All right. I've got that it's 5:29. I'm going to send you 2 sheets to work on. One is very basic, just reminding you about taking a shape and coloring in the fractional part. And then the second sheet is on simplifying fractions. And a couple of them on there are have a little bit larger numbers. You're going to have to do some thinking. You're going to have to do some dividing on those. Okay. So I've got that it's 5:30, roughly 1 minute till 5. Now it just changed to 5:30. So it's 5:30. We'll come back at 6. So give me just a second to send these to you. Work the problems, take a break, or take a break and then work the problems, and we'll be back at 6 o'clock. All right, so give me a second to get these sent to you.